The question of the day is, how does carbon dioxide in the atmosphere disrupt Earth's energy balance? The same question, really, expressed quite differently, is what is the greenhouse effect? We've talked a little bit about that at an ultra-simplistic way. I want to go a little bit more scientifically correct. So previously we've talked about greenhouse effect is that process by means of which molecules of carbon dioxide and some other substances interfere with Earth's energy balance, with the consequence that the Earth's surface becomes warmer than it would be in the absence of molecules of those substances. The oversimplified explanation that I've given you is that molecules of carbon dioxide capture or trap some of the photons of radiation that are emitted from the Earth's surface, which would otherwise go off into space, and so the Earth is left warmer than if those molecules were allowed to proceed through the atmosphere. Now, I want to make the point, first of all, that the greenhouse effect, it's called the greenhouse effect because greenhouses or glass houses, there's a picture here of a glass house that are used in agriculture, also maintain a higher temperature than if that structure was not around the plants. But the mechanisms by which this greenhouse maintains a warmer temperature and the carbon dioxide molecules in the atmosphere maintain a warmer temperature are vastly different. In the agricultural greenhouses, it's simply that the warm air in here is prevented from leaving by convection away from this contained space. In the atmosphere, the greenhouse gases selectively capture, trap, absorb photons of radiation that are going on their way out to space. There's no roof holding those molecules of air in. All right. So what is the mechanism by which carbon dioxide acts as a greenhouse gas? So you have this picture. Photons are leaving the surface of the Earth going in all directions. And the explanation we've said is that some of the photons are captured. Well, in fact, all of the photons are captured. When a photon collides with a molecule of carbon dioxide, the molecule absorbs the photon or absorbs the energy of the photon. We've got a philosophical issue we can talk about there. So the energy of the molecule increases. And what happens? The molecules of carbon dioxide vibrate faster when they have that energy. And it's said to be excited. Ozzy? So, Prof, I think I got it. Radiations are coming in from the sun, and all the photons that come from Earth and want to go towards space, they're all trapped. So, everything that comes from the sun is trapped within the atmosphere, and it's just going to get hotter and hotter and hotter and hotter because nothing can escape, because, as you say, all the photons are trapped. All right? Well, there's a bit more to the story. All of the photons are absorbed, but then, after a few milliseconds, quite quickly, the excited molecule, so-called excited, undergoes relaxation. That means it goes back to its ordinary condition of energy. And it does that by emitting a photon that has the same energy as the photon that was absorbed. Now, the photons from the carbon dioxide that are emitted by that molecule as it relaxes are emitted in every which way, every direction, some of them back towards Earth. So here's a portrayal of overly simple. Here's photons of radiation. We know it to be infrared radiation. leaving the Earth. This is the Earth blue, the blue planet. But now, when they hit a carbon dioxide molecule, there's a transfer of energy from the photon to the carbon dioxide, which vibrates quickly, faster than it was. It's excited, but then, after a very short while, drops back and emits a photon. And now, perhaps the new photon is going on its way to space anyway. Perhaps it's going this way. Perhaps it's emitted back towards Earth. Perhaps it hits another one and is absorbed and then is emitted back towards Earth. They can go in every single direction in the whole of three-dimensional space. The net consequence of that is that not all of the photons that are emitted from the Earth's surface get out into space. Some of them come back and are absorbed again by the Earth's surface. And so the Earth's surface is warmer than it would be if these ones were not absorbing, then re-emitting, and then sending some of them back in this direction. Fewer escape from the Earth's surface, from Earth's atmosphere than they would if otherwise. This is the greenhouse effect. Now, by the by, each time that an excited carbon dioxide molecule relaxes back to its low energy vibrational state, its normal condition, it's now ready to absorb another passerby photon that might be coming along. So carbon dioxide molecules are excited, relaxed, able to be excited again, capture another photon, and so the process goes on. I can picture them something like guards patrolling the atmosphere, watching out for these photons. And some of the photons get through the patrols and some don't. So, in summary, in very colloquial language, carbon dioxide molecules gobble up photons from Earth that are on their straight line trajectory towards space, and then they spit out other photons that have the same energy as those they gobbled up every which way. And it's pretty much as simple as that. So greenhouse gases are gases in the atmosphere that bring about the greenhouse effect. The greenhouse gas in the public eye is carbon dioxide. There are other ones: methane, nitrous oxide, fluorocarbons, a whole range of different sorts of molecules, and sulfur hexafluoride. And the most important one of all, which we'll come to talk about, water vapour. Aussie again. Okay, Prof, but why do carbon dioxide molecules absorb photons that are emitted from the Earth's surface? Why carbon dioxide? Why not the oxygen, the nitrogen? Just to say they're absorbed doesn't make much sense to me. Well, you're preempting me, and that's fantastic. Your question is exactly what I have here. Why do molecules absorb photons of radiation emitted from Earth? So this is even more deeply scientific than where we've just been, and we'll talk about that next session.